Hi everyone. Okay, so in this video we are going to move beyond dynamic programming and dive into one of my favorite topics in reinforcement learning: exploration versus exploitation. Honestly, this is a kind of optimization problem that I really love in computer science. So let me give you an example. Let's say you are in Italy, famous for its pizza, and you are being told that you are being told that pizza A, and also I'm gonna put this here, sorry for my drawing, pizza A and pizza B are the best in town. But here's the question, how do you really know for sure that they are the best? Maybe there could be a third pizza place, which could be this, let's see, pizza C, that might actually taste better, and you haven't tried it yet, right? So you have two options. You can decide to do exploitation, which is to keep going to pizza A and pizza B, the ones that maybe you already know and like you have been told that they are the best. Or you can also decide to do exploration, which is to try new random pizza places like pizza C, or different places to hoping to discover something that is better. Okay, you might never know. Now, in terms of policies, even though a policy gives you an action to take, always choosing the best action isn't always the best strategy, because if you kind of never explore, you might miss out on some important options. Now, this is the point of this video, really to show you different strategies that will help you balance exploration and exploitation during learning. And the first one is this. Okay, you can see, yep, the Epsilon-greedy approach. Now, here we have an epsilon here. What this tells you is and the epsilon is called the exploration rate. It is a number between 0 and 1, and it controls how much you explore. So here, with the probability epsilon, we explore. It means we pick a random action regardless of whether it is bad or good, irrespective of what the policy says. And with probability 1 minus epsilon, we exploit. So we pick the action with the highest estimated value, meaning we go for the option that we believe is the best. And here we are using a Q function, not a V function. So this is like this QS A prime kind of represent our estimated value of taking action A prime in the current state S. The argmax here is, it simply means we are selecting action A prime that gives the maximum Q value. Okay, so this is one approach. Another approach is this, the Boltzmann Softmax approach. Now this is slightly more sophisticated. This is a very simple approach. This kind of has this also has this parameter epsilon. This also has this t parameter. So this the policy as state A for action A essentially gives you the probability of choosing action A in state S. So unlike the epsilon, like this Epsilon-greedy approach, here we're not just picking an action outright, we assign probabilities to each action. This QSA again is the estimated value of taking action A in state S. We divide it, this is E, we divide it by T, the temperature. This is it controls how much we explore. So higher T means more randomness, more exploration, and lower T means we exploit. we focus on highest valued actions. So this whole term means we transform the Q values into positive scores. Higher Q values give higher scores. The term here at the bottom sums up these values across all actions to normalize the probabilities. I mean, making sure that they add up to 1. Okay. So, yep. So essentially, for each state, we compute probabilities for each action, and actions with higher probabilities have higher chance of being selected. So you actually do some sampling. So let me give you this example. Let's say you do this and you compute these values for pizza A, B, and C. They will actually sum up to 1. I mean, going to pizza, let's say at a particular state, you have an option to go to pizza A, go to pizza B, go to pizza C. And you do this computation, you get these values. Now, what you do is sample just one value. However, values with higher softmax have a higher chance of being selected. So here, a pizza A and B are most likely, but pizza C still has a chance. Okay. Yep. So this is the second approach. I'm pretty sure there are even more sophisticated approaches, but these are the basic ones I think you should know. Okay. Thank you for watching. Bye bye. Let me know if you have a question in the comments.